I'm a complete beginner on 10 gigs. I wanted to get into the band, mainly for ATV. I saw these LNBs mentioned on the forum. I thought that's got phase lock loop, that's interesting. But you still need to change the crystal, which is thought was less interesting. Then I saw on some of the French sites that they'd used the SUP 2400 to convert the low frequency output back into the satellite band. I thought that's good. You don't have to open the thing up and change the crystal now. So that was more interesting. Then I saw G4JNT's article on his tests on it, and it looked like it was good for narrowband. So that was even more interesting. I thought. Then I changed my mind. It's like if you change the crystal, then you can bring the output into an amateur band. At the moment, unmodified, it would be coming out about 618 megs, which is fine if you've got a scanner. But I thought, can you get it on 77s? That would be quite useful. So this is the LNB in question. Octagon, dual output, universal LNB. They've been around for donkey's years now. It seems to be the standard LNB for home use. And they have two local oscillators, and you can switch between those with the 22 kilohertz tone we heard about yesterday. And you can also select the polarization by giving it 13 volts or 18 volts. And the phase lock loop has a 27 meg crystal, and for the low, you multiply by 361.111. Strange number. And for the higher local oscillator, it's 392.59. I think there must be some division and multiplication going on there for those peculiar numbers. So standard LNB, good low noise performance, and very stable, of course, with having the crystal in there. So normally, frequencies coming out of an LNBs, the broadcast satellite band is 10.7 to 12.75. Satellite receivers can normally tune 950 to 2150. Obviously, that's bigger than that, so that's why you have to use the two local oscillators and effectively split into two bands. I don't think this is set in stone, but it seems to be quite popular that receivers will. More modern receivers will switch at 11700. You just tell it that you've got a universal LNB, and you put the frequency in you want to receive, and the receiver works out whether it's going to be on the low band or the high band and turns on the tone accordingly, and adjusts itself into this range, so it can pick up what you want. So normally, an unmodified LNB on the low band. The satellite transmitter frequency is 10.7 to 11.699, and you subtract the local oscillator, and it comes out in that range. And when you put the 22 kilohertz tone on, the high band, that's your local oscillator, and so that band minus that gives you this frequency coming down the cable. So now we've got our range is 950 to 2150, which is exactly what the receiver wants. If we want to use this for the 10 gig band, complications. On the low band, we want, just covering the whole band for example, the 10 to 10.5, subtract the local oscillator, that's the frequency coming out of down the cable, not in the range of a standard satellite receiver. And if we put the 22 kilohertz tone on, subtract that from that, then, of course, this is reversed now. The local oscillator is above the frequency of interest. Our output frequency is 600 to 100 megs, again, not in the range of a receiver. So that's why people have been changing the crystals to reduce these local oscillator frequencies, which will increase the output frequency and bring it back above 950 megs. Another way of doing it without changing any crystals is to use one of the SUP 2400 converters. We've been using these to move 70SEM DATV from 437 to 1963. So again, you can use a standard digital receiver and it's quite happy. You need a few modifications on it, and these are on the M0DTS website. There's two types of mods. Another set by 9FHB. They're simpler. The gain isn't quite as high. And really for 70SEMs you do need a preamp as well, because I think the gain's only about 10-15 dB or so when you do the M0DTS mods. And originally these were used in the US to move 250 to 750 up to 2150 to 1650. Then we heard a bit about using these low frequencies yesterday in one of the talks in the future. So that's a simple way of using this: standard LNB unmodified, standard digital receiver, and you can receive 10 gigahertz television. We look at some of the frequencies now that are coming out. It's getting quite complicated. Now we've got two local oscillators in the LNB. We've got a local oscillator in the SUP 2400. So we've got three local oscillators to deal with. This is the standard configuration, no modification, 27 meg crystal, low band multiplier to give us 9750, high band multiplier to give us 10600. So this is what happens if you try and receive our band of 10 to 10.5 gigahertz. Subtract the local oscillator, frequencies coming out of the LNB, as we saw before. Both of those are out of range of the receiver. But the SUP 2400s, you subtract those from 2400, mix down or up, and you come up with these two ranges. So these are now both, that's within the range of the receiver. This is, the low end of it is in the range of the receiver. Of course, above 2150 you wouldn't be able to use. So it's advantageous to keep the frequency above 250, because that's what the SUP 2400 wants, and it's also advantageous to keep the frequency coming out of the LNB as high as possible, because it does tail off. With these, not as badly as apparently as the older LNBs, but I checked on this analyzer yesterday, just looking at the noise performance. It was flat to about 500 megs, then just started tailing off slightly, then it was going about 1 dB every 10 megs. So the higher you can keep the frequency coming out of the SUP 2400, the better. So we need to use both high and low bands to cover our range and keep the frequency as high as possible. And if let's say we just only have a receiver. The more modern digital receivers, not so much choice of LO. The older analog ones, you can key in pretty much what you like within a certain range. But the new ones may only give you the standard ones. So if we assume the worst case, we can only set our receiver for a universal LNB, and we have to work around that. And let's assume it's switching at 11700 automatically and putting our tone on and going onto the high band. So the best split looks like this. If this is again with the unmodified LNB. If we have 10201 to 10500, if we receive that on the low band without the 22 kilohertz tone, that will come out of the LNB at 451 to 750, mix it with the 2400 meg here, and this is what comes out of the SUP 2400. Within the range of the receiver. But of course the receiver doesn't know we're doing this second mixing stage. It's assumed it's got a 9750 LO, and it doesn't know anything about this stage we've put in, so we can't put exact frequencies into the receiver like you can on 10 gigs. You just put with an analog receiver, say, without the SUP 2400, you just put in, on 23 centimeters, you just put in an LNB of 10 gigs, and if it's 1249, you just say the frequency is 11249, and the receiver's quite happy with that. But here we've got to do a bit of calculation to work out what to put in. It turns out this is what you put in for this range. So 10201 you put in 11699, 10500 you put in 11400, because of course the sub 2400 is the yellow is high, so you're effectively tuning backwards. And this is quite good because it's within the range of the sub 2400 coming out of the LNB. 451, it's only just started to drop off out of the LNB down the cable, so that's a fairly happy situation. If you want to cover the lower 200 meg, then it's best to go onto high band, turn on the 22 kilohertz oscillator, so the frequency out of the LNB is that minus that, 600 to 400. Out of the sub 2400 you subtract this from the 2400, and this is what's coming out of the sub 2400. And it turns out to keep the receiver happy, you tell it to tune 12400 to 12600 for that 200 meg range. And now we've got, because our LO is high here, the LO is high here, the two cancel out and we actually tune in the right direction. So a couple of examples. 10342, the frequency you put into the receiver is 11558, that's below 11.7, so it selects low band, 22 kilohertz off. It's actually using this local oscillator. If we want 10065, we want to go on this range here, and the receive frequency you put in is 12465. Seems a bit complicated, but just two things to remember really. If you're in this range, you forget the first two digits of the frequency, just look the last three digits, 201. For this band you just add them to 12400, and for this band you subtract it from 11900. So really just two things to remember. So very simple to connect up. LNB, sub 2400, satellite receiver, and you can receive 10 gigahertz ATV. Normally the mods for this, for 70 SEMS, you take out one of the ferrites. There's a ferrite at each end to feed the power from the SAT receiver through it and up to the LNB. And normally we take one of those out because in case the 70 SEMS antennas are dead short. But for this use, of course, you have to leave both the ferrites in, so you actually power the LNB. Looking at the narrowband now, we want to receive this on an amateur band. 70 SEMS really is the only option. It's by the time you mix down to 2 meters, the roll-off would be about another 30 dB. So 70 SEMS is about the only option. So with an unmodified LNB with a 27 meg crystal, 22 kilohertz tone off, the local oscillator is 9750, our band of interest 10368, 1070, actually coming out of the LNB down the cable, 618 to 620. We can try the high band, see if it's any better. 22 kilohertz tone on, local oscillator on the LNB 10600, subtract this range from that on the high side now, and you end up with 232 to 230. It's fine if you've got a scanner which will do those, particularly on SSB if that's what you want. But if you only got an amateur band receiver or transceiver, then you're a bit stuck. So I thought, what can we do with the crystal to bring out the signal in the 70 SEMS band? And with the multiplication factor of 361, you've only actually got about 23 kilohertz range of crystal which will hit the 70 SEM band. So, and that happens to be around the area of 27.5. So I had a look at what crystals were available off the shelf, and the only one I could find was one on eBay, 27.5. It turns out if you pull that to 154 Hz low, you end up with a local oscillator frequency. You multiply it by 362.111. You end up with a local oscillator of 9930.5. So when you subtract that from our frequency range, you get 437.5 to 439.5 coming out the LNB. 77 receiver, you're okay now, and it's even tuning the right way. I did try pulling the crystal a bit lower, another kilohertz, about 1.3 kilohertz further. Would bring you down to 9930.0, which would give 438 to 440, which would be a lot more convenient. But it's only a sample of one, but I found when I did that with extra padding capacitors on the crystal, it tended to warble a bit. Now, it could be something else, but it's something I need to look at. But so I thought, well, stick with this for the moment. It makes the maths a bit more difficult, but it's not too bad. So narrowband connections, a bit more complicated. You have your LNB on vertical polarization. You have an FT piece and then normal connection to satellite receiver. Or you can just feed it with 12 volts, that's all it needs. If you're feeding with 12 volts, then that selects vertical polarization. Of course, if you've got a feeding it with a satellite receiver, you can select high or low as you want. So this means if you're tilting your dish over, you have to make sure you may have to twist the LNB just to get the right polarization. An F2BNC adapter. These, of course, are available on eBay. Blocking capacitor to keep the voltage from the cable off the rig. I found the easiest way was a right-angled BNC plug. You can just take the top cap off and use a 1206 size surface mount capacitor. That fits in just nicely. Attenuators, because of the gain we saw yesterday, 60 plus dB gain, far too much for the receiver, so about 20 to 30 dB I reckon is about right. And then straight into your receiver. It's important to get the attenuator on the correct side of the blocking capacitor. Unlike the first time I tried it, and it had 12 volts on it, it was dissipating 3 watts. This is the tends to look like Emmerdale milking parlour in the arrangement, but it's so there we have LNB, the T-piece, FT piece, BNC to F, the cable with the blocking capacitor in, with a dot to remind me in case I start measuring it later and think it's gone open circuit somewhere. Then it's actually 40 dB of attenuation on there, and into the back of the FT817, which is playing up. We'll see if I can demonstrate that at the end. Of course, with you have 2 outputs on this. You can leave one output completely unmodified, and the other output's modified for narrowband. There's no reason why you can't use the same output, the modified output for TV as well. You'd have to juggle around with the frequencies we saw before. Just do a bit of recalculation. So you can receive satellite, you can receive ATV and narrowband at the same time from the same output with the same cable. You'll be changing the impedance, of course. You've got an extra 50 ohms on those, that will have some effect, but there's usually so much gain flying around that maybe not really an issue. So to the mod itself, this is the unmodified one. So the idea is to take out this surface mount 27 meg crystal, replace it with the 27.5 meg crystal. I couldn't find the surface mount, it's only a leaded variety, so the plan was to just insulate below the crystal, twist the wires out, and just put it back where it came from. Fortunately, not having any fancy desoldering tools and being a bit ham-fisted, I ripped the tracks off the crystal. And a close in, I didn't actually rip these off, to be fair. I just ripped these two off. I took these off manually, but I tried soldering irons at each end, putting solder on, but I think you need a proper hotter desoldering tool. So that's two I've done now, and two I've done this to, but it's, fortunately, I don't know why, but it just seems, oops, like a waste of components. Here are two pairs of 0 ohm resistors. Sometimes you put a series resistor in with the crystal, but these are 0 ohms, but it does make a handy place to solder things back onto when you make a mess of it. So there we see the the repair, and I scratched off the ground plane here and just put a couple of capacitors, about 33 PF, gets it nicely on frequency. So these are the tests. I've only had 2 chances to actually try this, so I won't be able to get any 10 gig from home, not a great location. But we put on a local World Amateur Radio Society put on a special event at Bitson Hill Lighthouse for the centenary of the extinguishing of the light. So that's got a wonderful takeoff, and Winter Hill, 1,500 feet, line of sight. G3SMU has a permanent transmission on 10342, so that's a handy signal, and Bolton the Wireless Club also went out for the day, and we received those at the lighthouse, no problem, very strong signals. Just one comment on that, I only had 2 opportunities to try this, and the first time the receiver had a fault on, Pace MSS 508. Certainly a very strong, fully quieting picture, but the audio, so the video coming out seemed very low level, and it wouldn't lock. You could see call signs, but it was very dark, and it was scrolling across the screen. Later found that had a fault on it, wouldn't drive the voltage on the LNB output properly. So I tried another MSS 508, and that did drive the voltage, but still got the strange low video. So I can't see anything in the system that would affect the frequency modulated signal and bring the level of the video down. So there's something else going on somewhere with the monitor or the receiver combination. Narrowband tests. There's a GB3XGH in Rochdale, and we received that very strongly at GB2BHL Special Event Station on Bitson Lighthouse. That's about 200 feet. 66K, it was strength 8 on a 6010 dish, and it was even audible without the dish at all, with the CW filter on the yeah. Of course, having Winter Hill a few degrees off the path of 1,500 feet could be an advantage. It's difficult to tell exactly where it's come from. It did seem quite wide and go a bit wobbly as I turned left onto the hill. So, but really ought to try it without that help in the way. Are we doing for time? Okay. So let's just see if I can demonstrate it. Just a few photos of the. Here's the path. It's this is from Google Earth. I don't think it takes into account the Earth curvature. So it's that's the beacon at Rochdale. That should be GB2BHL at the lighthouse in Birkenhead. So it's a bit spiky. I don't know Rochdale that well. I'm not sure. You'll have to look it up on the internet. And
you see Dave Wigley out on the antenna range. He actually runs these beacon keeping.
So here's the lighthouse where I was. Liverpool appears to have disappeared off the map completely. And Winter Hill is round about just by Bolton, around there. So it's a handy static repeater, and Rochdale is there. And just a few photos of the test installation. That's on the parapet of the lighthouse, looking back at the old Bitson Observatory. And you can see what the takeoff's like, the Welsh hills in the distance, hills of North Wales. That's the takeoff vaguely in the direction of the beacon. So it's not very high site, about 52 metres at the base, and the highest point on the Wirral Peninsula is about 110. But the takeoff is just fantastic from there. It's about 2 miles from the coast, 2-3 miles in any direction, apart from south. That's the actual building itself. Just crying out for an ATV repeater, isn't it? But, we live in hope. It's now privately owned. It's a Grade 2 listed, so not sure what we do for antennas. Maybe a surreptitious extension of the flagpole with some slot antennas in it. Right, I'll just see if I can demonstrate it. The rig's been playing up. I think it's on its last legs, this 817. We have some power locally. They all seem to be full. No, there's one. Got one. Got one. That's coming out on 438.184, so probably a touch low. You can tell the crystal's still warming up. You can change frequency by doing that. I mean, it's like the Earth's magnetic field, you think? Seems a bit more warbling than it was in rehearsal. There's a strange thing, you can actually hear it without being connected. Now, I reckon it's because there's such a high level of signal coming off the cable.
That really shows the actual amount of gain in the LNB.
Yeah, it's either that.
Brian, you can see the claim to be wireless. Wireless. Does that make it wireless?
Yes. I didn't know these LNBs came in a Wi-Fi version. It's,
Don't say that, with our beacon here, there's about maybe 20 dBm. It's 618X, so you can see the sensitive receiver, 120 dBm.
yeah. So it's a little settle down eventually. Of course, it's a bit microphonic, but it's.
Try some freezer spray, just another test onto the casework.
Going down.
Just killed it.
Yeah, if you did that with a DRO.
Absolutely, yeah. Be off for a week.
That's it, yeah.
Good. Okay. Well, thank you, Brian. Yeah. We're really going to move.
Okay, my interest really was on the narrowband side of these wonderful LNBs with all this gain, and as you know, we've actually got a reverse beacon set up now on 10 gigs at Melcop, and I started looking at these particular devices in terms of getting greater stability, and to take out the existing 27 meg crystal, which is defined as quite rubbery, as you saw, and it's not temperature compensated, was to try and replace it with a VC TCXO. And rather than have some slides, I've got a unit here under this document camera that you can probably see, And the plan is, if there's sufficient interest, is to do a board. So you can see where the crystal was on those pads there and there with that pointer. And I've made a small little board there, and that is the VCTCXO, that little device there. Now, it is extremely difficult to put down onto a piece of FR4, point FR4. So my plan is to, if there's sufficient interest, to have a board produced with that 1V8 regulator. You can see that little device there, that SOC23 device, to put that onto this board and make it available with the VCTCXO to give much better stability for the narrow band portion. So that the mod's very, very similar to the Crystal 27.5 meg, and to actually produce this on 27 megs dead or any other frequencies to come out on 77s, but to give greater stability. So this board was removed from some kit that we use at work, which is on 27.162, that brings the LO out at around 559.08, and I'll let you have a listen to it when I put the lid back on. One point is to always, when you're playing with these, to put the casting back on. It will take off because there's areas that need the actual cavities, and it will fly all over the place and be unstable without lid back on. So while you're working on it, you've got to ensure that this is all oscillating correctly, the right levels into the device. And you can see my tapping point, which is about down there on that 0 ohm resistor. It's difficult, this, I'll have to turn around a bit. So you can probably see that point there. There's a capacitor onto that. The plan is to make this board and cover where the crystal was with the lands that then can come out onto the track work. So really I'm just looking, is there sufficient interest to take this to the next level? Because I can have these tiny little boards manufactured onto the edge of panels that we get basically the boards for free. Okay, I'll take some questions if that's all right, Peter.
Might be worth adding a comment, mostly from the wideband, that if we lose the bottom 200 megs, we'll all be interested in moving up the top of the band, so repeater just probably will go right up towards 4, 7.
Yeah. Yeah, I mean, just give me that one again, Peter. I wasn't.
If from the comments Murray made yesterday, we lose the bottom bit.
Yeah.
I'd be a little interested in doing the 10G to 10.1. The bottom bit anyway. We'll lose it probably.
Yeah. Okay.
So we'll be interested in everybody shifting up.
Okay. The point from Peter is, and Murray's point regarding the proposed band plan, is to actually move up to beyond 10.5. I think is the towards that sort of sector. So really, this is down to the choice of the VCTCXO if we need that sort of stability. And the VCTCXOs, there's MOQs on the minimum order quantities, so that's why I need to be pretty certain that we're going to use them over a period of time. And you know, if that's years, that's fine, but it's really to kick off whether the board is viable, phase 1, and then to actually get the VCTCXOs to stabilise them.
A couple of points, Kevin. You were talking about using this for narrowband as much as anything. Have you looked at the phase noise if you get at 10 gigs from that TCXO?
Yeah, Jeff's point is regarding the phase noise, and it's a very, very valid point. I think it's fair to say that the phase noise of this particular model, and I haven't sampled thousands, is adequate for SSB. But it's always a concern is the phase noise of these devices. It does improve with the VCTCXO compared to a standard 27 meg crystal.
I'm sure you could work it out easy enough in the spec sheet anyway. But the other allied question is, you usually have an image filter in these LNBs, which rolls off to reduce the image and the local oscillator leakage or whatever.
Yeah.
Does it have a reduced sensitivity around the 10 gig region versus 10.7?
Okay, Jeff's point again is, does the actual, I mean, the lack of image filter, does it actually roll off significantly? And there's still sufficient gain down at 77s, that's what we've found so far. And I think we're still experimenting with them, to be fair, Jeff. And this is just a way of improving on the rubbery crystal that's standard to improve it.
I'm trying to get hold of one, so
Okay, well, I have got one for sale if you've got one. Yeah, yeah. Can I pass over to
Yeah, so I slipped up and didn't include Brian in any questions, so I suggest if you've got any questions for Brian, we have them as well now. So.
Question here?
Yeah. In terms of the narrowband facility, I mean, are you anticipating you bringing it out on the same as the 27.5 crystal, or are you going to try and align it with 430 to 432?
Yeah, it's a valid point. The Clive's question is, do we plan to bring it out at the 618, I presume, or down at 432? I think this is a choice of where we want to pick the VCTCXOs. We want that stability, and I think that's where we are at the moment, is deciding what we want as a group for that, and that's why I'm really looking for a discussion on this of what we want.
Well, I mean, in terms of using it as a narrowband facility, I mean, clearly it's going to make matters a lot more convenient if you can just use your frequency readout by just deleting the first digits.
Correct. I mean, going with 27 megs, it comes out at 618 megs. That translates from 10368 nicely. You want a number that's easy to be able to use.
Absolutely.
Yeah. Okay.
Is the synthesizer chip a fixed frequency determined by your wiring, or will it be settable to different frequencies from outside the LNB?
Okay. The question is the frequency determined by the wiring or by the crystal frequency? I think, is that correct? It's by the actual chip itself, the code within the chip, the synthesizer, and the crystal is the reference oscillator.
Feed that with the information that it needs to set particular division ratios. I'll talk to you about it later. Obviously, don't understand.
I think they said yesterday they couldn't get the information.
Yeah, I think this is what we're struggling with. We haven't got a full data sheet of that particular chip.
Okay.
Or what we do know, we can actually shift the LO by moving, and we know the multiple that we're working with from the reference crystal. I think that's fair to say, unless you want to add anything to that. Okay, any more questions?
What's the range of the VCOTX?
The question is the range of the VCO TX.
The replacement synthesizer chip. What sort of range of frequencies will it cover? Or is it fixed on one specific frequency?
It's fixed, yeah.